Right. So last week we spoke about mostly binomial distribution. Today we are going to, not last week, before that, today we are going to start with a new distribution. Right. Uh, mm, we learn about discrete distribution. Up to now, we learn about discrete distribution. All right. We learn about discrete distribution. Can you all hear? Is there any voice disturbing you all?
Yes, sir.
Is it clear or is it clear? Is there any other voice disturbing? I need to get the answer from you. Nobody's speaking out. Is there any outside voices disturbing you? No, it's okay. Right? Okay. Right. If you feel anything, just send me through chat. All right. Send me through chat. Send me through chat. Even if you are unable to speak out, send me through chat so that I can read what's your problem. Or even when you answer, you send the messages through chat. All right. Right. Shall we start then? Is it okay? Shall we start our lectures? Yes? No? Peony. Yes, Peony. Kamsavatani.
Yes, sir.
Yes. So we can start. Right. Up to last time we talked about discrete distribution. You know what is the difference between discrete distribution, discrete data, the data that we deal with discrete data, right? So that data basically distributed with a discrete distribution. So we talked about probability distribution of a discrete random variable, discrete random variable. Now we are going to look at probability distribution of what do you call the continuous variable. What is the difference between continuous variable and discrete variable? We spoke about it. What is the difference between continuous and discrete? In a continuous variable, there are many numbers or millions of smaller subunit between two major units. Right? So that is basically called as continuous variable. Whereas in the discrete variable, you have full numbers, number of chairs, number of animals, number of houses, number of classrooms, number of farmers, all are discrete. When you talk about the farm, each farmer has extent, land extent. Land extent, is it a continuous number or is it a discrete number? Land extent. Land extent, is it having a full numbers or is it having a continuous? Yes, it is continuous. Why? Because it is one farmer can have 1.2 hectare, another farmer can have 1.5 hectare, the third farmer can have 0.7 hectare. So it is actually a continuous data. The extent, land extent, is a continuous data. Fine. So under that this continuous variable, we are going to talk about what type of distributions are available. The first distribution, which is a natural distribution, which is called as normal distribution. The first distribution under the continuous distribution is called as normal distribution. Normal distribution, right? The name normal distribution. So this normal distribution, right? So this normal distribution is actually a continuous distribution. When you talk about normal distribution is the most important of all probability distribution because it is the mother distribution. We would say it is a kind of mother distribution of all the distributions. I will come to that why we are talking about mother distribution. So among all the probability distribution, the most important distribution is the normal distribution because most of the statistical tools or statistical procedures or statistical analysis are based on this normal distribution, right? Therefore, the most important distribution is the normal distribution, normal probability distribution, right? Let's look at some of these characters and how these normal distributions look like, etc., etc. The probability density function of a normal distribution or of a normal random variable, right? Can you remember the probability distribution, which is based on the probability density function of a discrete random variable, binomial distribution? That is based on, right? If you can remember, that is something like we have look at the px, right? Probability of x is equal. Can somebody remember? Factor of x n. Can you remember? Probability of p to the power x into 1 minus p to the power n minus x. So this is the probability density function of what? Binomial distribution, right? Similarly, let's look at what is the probability density function of normal distribution, normal random variable, right? This is how the formula is given. You don't need to remember the formula. We don't expect you to remember the normal distribution formula, right? But you should understand the formula. You don't need to remember the formula, but you need to understand. It is same as the earlier case, P probability of x, right? Probability of x. So here, similarly, the probability of x, this is also probability of x, which is a continuous random variable, is given as 1 over, what is this? Now we'll have to tell precisely what it is, sigma. How do you call sigma? We have introduced all these terminologies. What is this sigma? Anyone? Arosha, what is this sigma? Yadurshi, what is this sigma? How do you call this sigma? There's a name for this sigma. What is that? Arosha, can you all remember?
Population.
Yes, what is that?
Population.
Population? Population? Population part is correct. What is that? Population?
Variance.
Population?
Deviation, sir.
Population mean.
Then what is this?
Population variation.
Mu is mean value, sir.
Variance.
Sigma is standard
Mu
deviation.
is
Exactly,
population
exactly.
mean. Sigma
Yeah.
is population variance.
Not deviation, population standard deviation.
Standard deviation. Sir.
Yeah, don't forget that. So this is population mean. This is population variance. If you take the square root of population variance, you will end up with sigma, which is population standard deviation. So this is 1 over sigma, which is population standard deviation, into square root of 2 pi. What is pi normally? 22 upon,
Normally is a constant value.
yeah, 22 upon 7, right? Pi. 2 pi. I don't know whether you have done the mathematics. 2 pi. What is the angle of one circle?
3.14.
No, no. I am asking if you say the angle of one circle.
360.
Yeah, 360 degree. So that we can write it as 2 pi. 2 pi radians. We call it as 2 pi radians. Right? Okay, that you don't want, but 2 pi radians. That is the angle in terms of radian in a circle, in one circle, one single circle. Right. So that is about 2 pi multiplied by, what is this? This we have seen. This is called as exponential. Last time we discussed this, right? In the calculator. Some of you have E. This is exponential. If you take log with the base E, then we call it as, that is natural logarithm, ln. That is ln. That is, if you take the anti-log of ln, this will be E. Right. So e to the power, right? E to the power uh, e to the power minus half into, this is the value of this random variable, any value of the random variable, minus, you are familiar with this mu. What is this mu? I have already named it earlier, population mean, divided by population standard deviation, whole thing square. Right? So that is, you don't need to remember this formula, but you need to understand the formula. That is more important. Right. So this value, probability value, that is the interesting part of the probability. Right. So this probability density function value, this x, the random variable, this actually x is the random variable. This x can have any value from minus infinity to plus infinity. So x can have any value from minus infinity to plus infinity. X, right? So this distribution looks like that. So basically, this distribution is look like. Can you just tell me whether this distribution is symmetric or whether this distribution is skewed? Somebody, whether this distribution is symmetric. How do you call this distribution? How do you call this distribution then? This is symmetric. Is this symmetric? This is skewed.
No.
Skewed to what side? Skewed to
Right side.
right side. This is skewed to right side. Is this same or different? It is different, right? So this is more or less symmetric. So that is the speciality of this normal distribution, right? Normal distribution. That is the speciality of normal distribution. It is symmetric. Symmetric about the mean. So in the middle exactly you get the mean, population mean. If you cut along this mean of this graph, it is exactly two halves, two symmetric portion, right? So that is important phenomena of this distribution, right? So it's look like this, some of the characters, bell shape, right? This is a bell shape. You should remember. Can you remember bell? Huh? In the temple, you have different bells. In Koil, in Pansala, you have bells. How the bells look like? Something like this, isn't it? So that is why we call it as it's a bell shape. For example, if you have a distribution like this, is it a bell shape? This may be symmetric. If you cut it here, this may be symmetric, but it is not bell shape. But here, this is bell shape, as an example. So the character, the important characters out of different characters, bell-shaped character is one of the important characters, bell-shaped, right? Then the data are symmetrically distributed. So that is what we said. If you cut into into the middle, then you will have two halves. So it is symmetric around the mean. That is what I said. If you cut exactly at the mean, it will be symmetric. The other important thing is you will find in a symmetric distribution, what are these three features? Mean, median, mode. We learned on the first lecture. What is that? Mean, median, mode. How do you call this? Measure of center, isn't it? Measure of center, mean, median, and mode. So this is mean, median, mode, measure of center, which is actually exactly in the middle of the distribution. So that is the other speciality of this normal distribution. Also, the other important, the person called as Gaussian, is a statistician, lived in 1800, I think late 1700, from Germany, Gaussian. So this also sometimes called as symmetrical distribution or Gaussian distribution or bell-shaped distribution. Sometimes in certain books, they are referring with different names. Normal distribution is a symmetrical, Gaussian or bell-shaped distribution, right? We will look at, we will try to clean that. Right. The normal distribution is fully defined by two parameters. Look at what are the parameters in this formula. Look at in this probability distribution, what are the parameters coming into picture? We learned about several parameters. This is one parameter, population mean. So tell me, what are the parameters basically?
Standard deviations, mean,
Yeah.
rate
Mean, yes, mean and standard deviation basically, right? So these are the two parameters. So standard deviation mean actually it is variance. I mean, if you know the variance only, we can find out the standard deviation. If you don't know the variance, we cannot find out the standard deviation. Is that correct? So if you know the variance only, we can find out the standard deviation. So basic parameters here, two parameters in the normal distribution. What are the two parameters in the binomial distribution? What are the two parameters in the binomial distribution? Can you remember? Arosha, Peony, Jeffrey, can you remember? We said a random variable is x, distributed binomially. You have all these notes with, what are these? Can you remember? Can you remember? Yes? Anyone? Since you are not answering.
Yes.
Yes, binomial distribution. What is this? N is the
Number of trials.
number of trials. P is the probability of
Probability
getting
of success.
that particular
Success.
probability of getting that particular random variable, right? Whatever it is, whether you get head or tail or whatever it is. Similarly, here in the normal distribution, you have two parameters, input parameter, mean and the standard deviation. Basically, mean and the variance, right? So this is our formula. So these are the standard deviations that we have talked about. That is the mean that you have already answered. So in the normal distribution, it's a bell shape and symmetric about the mean, right? This is bell shape and symmetric about the mean. Unlike the range of uniform distribution, for example, the normal distribution range from minus infinity to plus infinity, right? That is the important part. It can range from minus infinity to plus infinity, right? Let's look at some of the how the normal distribution looks like, right? How the normal distributions looks like. First, we will understand about the distribution. So today, everybody should have that table copies, right? I'm going to explain that tables today, right? Some features of the normal distribution. This is the normal distribution, right? I will put it as ND, normal distribution. This is a typical graph of a normal distribution. What is in the middle? This is mean. What is this sigma? Standard deviation, population mean and population standard. If you take the normal distribution, the total probability under the area. So let's say this is the total probability under the area, right? In a normal distribution, all right? I will use right. Now, when you talk about normal distribution, so I simply draw a normal distribution. Don't worry about the bell shape. Assume this is a normal distribution. So in this normal distribution, when you talk about the area, right, in such a way, we have made the total area. I will put it as TA, total area. You write it as total area. Don't write it TA, then you don't remember later on. Total area is equal 1. Total area under the curve is 1. So in other term, you learn the mathematics, right? Have you learned mathematics? So we have the function of x, which is explaining the normal distribution. Y is the function of x, which is explaining the normal distribution. Now, if I want to find, let's say, according to that formula, this is the function. If I want to get the total area under the curve, what should I want to do? I want to integrate this function. Have you heard about it? From minus infinity to plus infinity, right? With respect to x. If you integrate, this is a definite integration. If you integrate this function with respect to x for the range of minus infinity to plus infinity, you will end up with the answer 1. So the total area under the curve is 1. So in other term, total probability is 1. Total probability is 1. Is it clear? Right. So now you see here the probability is given in terms of area. Probability is given in terms of area. So that is more important. In continuous data, the probability has been defined by the area. So that is the most important message. Most important message is the probability is equal area, where in continuous data, when we calculate the area, which is giving the probability. Right. Okay. Can you remember the term I used, point probability, in binomial distribution? Can you remember the point probability? Yes or no? Anyone? What do you mean by this point probability? Let's say I'm putting a distribution of the height distribution of the students in the university, right? So the mean value, let's say I'm just plotting the height distribution of university students taken from Jaffna University, right? So the average height is 165. The average value is 165. This is in centimeter, right? So this is how the distribution looks like. Now, if I want to find out the probability of X, those are the students. X is the continuous variable. Height of students studying at University of Jaffna. Can you remember in the first day we talked about students' average height? So X is actually distributed normally. This is a normal distribution. So this is how the distributions look like. So we found that the mean value, or in other term mu, for this example is 165. So it is in centimeter. So mean value is right. Now my question is, what is the probability of the students who are studying at the University of Jaffna having height less than 165? What is the answer that you would say? We said the height of the students studying at University of Jaffna is distributed normally, right? So under that assumption, this is our mean value. Can you tell me, assuming this is the total probability is 1. So that what is the probability value for this? Anyone?
1 minus that area
Yeah.
in the 165.
Yeah, what is this area? So we want to find out this area. What is that area? What is that area? What is this total area?
1.
Yeah, if we consider total area 1, what is that area? The marked area. What is
1
that?
minus
1 minus
0.5, sir.
0.5. The answer is 0.5. Why? This is not 1 minus. Why? Because we said, if we say it is a normal distribution, it is splitting into 2 halves where at your mean. At your mean, it is symmetric. So our mean is 165. So this is 165. If you put a line here, it will split into 2. So it is symmetric. So what is this area? The people who are having the height less than the height less than 165. All right, which is 0.5. Similarly, if I ask another question, the height of the students who are having more than 165 centimeter, what is the probability?
0.5.
Again, it is 0.5. Now, I will ask a question, what is the probability of x having a value 165? What is the probability of x having the probability of x having 165? Anyone? Think and answer. Anyone? Guess what would be the answer? Because we already said the probability is based on the area, isn't it? Probability based on the area. Now tell me, what is the area for x equal 165? Is there any defined area? If there's a defined area, what is the area? Anyone? You can answer.
0.
Yes, good. You can
0.
answer. Yes, good. You can answer even through chat if you are unable to. So the value is 0. Why? What is the reason value is 0? Because this is what we called as, how this is called as, earlier I mentioned this. How do you call this phenomena? What is point probability? This is called as point probability. Point, exactly we point it. When you say probability of x equal 165, mean it is a point probability. Point. To that point, what is the probability? Again, if I ask what is the probability of students having height 168, for example, again it is 0. Why? Because no area can be measured using this. So this is 0, this is 0. Suppose if I ask what is the probability of x in between 165 and 168 as an example. Is it 0 or is this have a value?
Have a value.
It has a value. Why? Because you see, we are talking about another area, right? We are talking about another area. What is that area? So let's say I'm just drawing. So this is 168, right? So now my question is, what is the probability of this? If you find the probability of that red color, so it will be the answer for that. How to find out that we will see little later, right? So this has a, well, this is not a point probability because the area is defined. But here, the area is not defined. The area is not defined. So this is a point probability. So what about point probability in continuous distribution? Make a note of it. In continuous distribution, right? In a continuous distribution, PP, point probability, there's no point probability. no point probability. Or in other term, point probability is always 0. No point probability or point probability is always 0. But in binomial distribution, can you remember tossing a coin three times? Tossing a coin 3 times, getting head. So this is even, this is probability. Can you remember? 1 head is possible, 2 head is possible, 3 head is possible. Sorry, 0 head is possible, 1 head is possible, 2 head is possible, 3 head is possible. What is the probability? 1/8, right? So 0. This is 3/8. This is also 3/8. I'm just putting this values which we already found in our previous lectures. 1/8. Can you remember a table like this? Yes or no? Yes, yes, yes. Right. So this is a binomial distribution. Now here I can ask a question. What is the probability of having x equal 1? So in other term, what is the probability of getting 1 head in all 3 tosses? The answer is 3/8. Isn't it? So this is called as point probability. In binomial distribution, you have the point probability. In a continuous distribution, in a discrete distribution, you have the binomial distribution is a discrete distribution. In discrete distribution, in generally, we can say there's a point probability. Point probability can be found. In a continuous distribution, there is no point probability. Is it clear? I can see only Yadurshi. Is it clear? Preetivagaran, is it clear? What is this point probability?
Yes, sir.
Yeah. Uh, Anushalini, is it clear? Sri Tivagaran is missing.
Yes, sir.
Did you understand?
Yes, sir.
Right, good. What about Anushalini?
Yes, sir.
Right. Did you understand what is this point probability or continuous in continuous distribution and discrete distribution? In discrete distribution, there is a point probability because we are not based on the area to calculate the probability. But in continuous distribution, the probability will be based on the area calculation. So for a given random variable, to find out what is the probability, which is called as the point probability. So always point probability is 0 for continuous distribution. Clear? All right. Keep that in mind. So we will move to the other aspects of normal distribution. Now we will talk about normal distribution. Right. So this is the typical normal distribution that has been given. Right. Time to time I will use the pad also. Now you see, when you talk about the area, what did we say about the area? The total area is
1.
1. So based on that only, we are going to see how this area can be splitted relating to our 2 parameters. What are the 2 parameters that is relating to normal distribution? We already said 2 parameters relating to normal
Standard
distribution.
deviation and mean.
Deviation
Right,
and mean.
right. So how we can talk about these areas, which is actually reflecting the probabilities in terms of these 2 parameters, mean and the standard deviation. Using mean and standard deviation, how we can look at the probabilities or basically the areas. Clear? Right. So in this normal distribution, this is the mean, no problem. Mean plus sigma. So that is always a positive sign. Mean plus sigma, and mean minus sigma. That is mean minus sigma for any normal distribution, right? Suppose, let's say if I have mean is, as an example 165, right? Sigma, I'm just taking an example. Sigma is let's say 5, right? So can you tell me what is mean plus sigma and mean minus sigma? In our height example, mean plus sigma is 170.
170.
Mean minus sigma is 160. Right? You see, this is an example. Huh? Don't worry about that values. So you see, practically, if you do it, so there's a range. So I'm just marking the area, right? I'm just marking the area. So what is the area that we are talking about? I will put it in red in color. So this is the area that we are talking about. So that area is a constant value. That area is a constant value. So probability of mu minus sigma in between mean minus sigma and mean plus sigma is always having an area of 68.3%. Or in other term, probability, total probability is 1. That is a speciality. Total probability is 1. So this is 0.683. Clear? Similarly, if you come to the second range of value, so that is, I will put it in blue color, right? The second range of value, it is mu minus 2 sigma and mu plus 2 sigma. So mu minus 2 sigma mean, in our example, what is the value? 100
55.
55, right? Good. That is 155. 2 plus sigma, mu plus sigma
75.
175. You see, so that area covers the whole area which I am painting with the blue color, right? So in other term, in our example, for this particular example, this is a height example now. So we can ask a question. So what is the probability of students, or what is the percentage of students, or what is the probability of students who are having the height between 160 to 170? So the answer is 0.683, or in other term, in percentage, how do you call? Roughly 68% of the students are having, or 68% of the students studying at University of Jaffna having height in between 160 to 170 centimeter. This is how we can interpret, right? So the almost 68% of the students who are studying in University of Jaffna having the height range of 160 to 170 centimeter. Similarly, for the second example, we can say students who, out of students, almost 95.5% of the students, 95.5% of the students who are studying in University of Jaffna having height in between 155 to 175. Right? The third one, mu minus 3 sigma, the range of probability between mu minus 3 sigma and mu plus 3 sigma is 99.7%. Or in other term, 0.997. You should remember this concept. I said initially you don't need to remember the formula of normal distribution. That is not necessary. But this is a concept. This you should remember. If I ask any questions, what is the range of this value? You will have to give this probability value. This probability value. This will not never change for a normal distribution. Right? This is fixed value. So you should remember. Is it clear? Right. Any questions? If you have questions, you can put it on chat as well, right? I can read the question. Some questions I can tackle immediately. And if not time permits, we can take it up at the end. That is also possible. You can ask any questions. I'm not going to blame anybody, so you can ask any questions. Is it clear about this calculation in normal distribution? If not, we can repeat it. Sri Divagaran, is it clear?
Yes, sir.
Okay, so do I want to repeat it or no? Yeah? How about Sahana? Sahana Jaya Rasa.
Yes, sir.
Yeah, did you understand?
Yes, sir.
Right, good. Okay, so we will further move, right, to the other slide. Just I clear all drawings and then come to that. Yeah, so this concept you should remember, because that will never change for a normal distribution. This, especially this probability values will never change. Right, now I will come to a question which I have put up earlier. Now, right, now you see, we said this is easy. Finding out the probability of probability of x less than 165, we can find out, no problem, right? Finding the probability of x greater than 165, it is also easy. Finding probability of x equal 165, that is also easy according to our definition, it is 0. Now talk about this, finding out the probability of x which is having a range of value 165 to 168. So this area that we are talking about, all right, this is the area that we are talking about, right? This is the area that we are talking about. Okay, so now how to find out this value? To finding out this value, because this is a normal distribution, distribution values vary from variable to variable, right? So what we are doing is basically I will use another. Right, I will use what basically, yeah, there's a one chat, I will look at it. So how to fix that memorized values as fixed value. I didn't understand how that memorized value.
Can you hear me, sir?
Yeah, I can hear. I
Sir,
can hear. Yeah, I can hear. Can you all hear?